Hi, my name is Joel Nitta from the University of Tokyo, and today I'm very excited to present taxastand and dwctaxon, a pair of R packages for standardizing species names in Darwin Core format. I'd like to mention that you can find the slides I'm showing today at this URL, joelnitta.github.io/biodigi2022. So species names are the glue that connects datasets together, whether that be occurrence records, trait data, or DNA sequences. If we want to connect these together, that's generally done using species names. However, we run into a problem in the form of synonyms, or different names that apply to the same species, such as this one here, which I would call Cryptonomys minutum. But if different databases use different synonyms, then these linkages break and we can't connect the data together. Now, that's not such a big deal if we only have a small amount of data. But in the age of big data, it's really just not feasible to deal with this manually. We need to rely on software to resolve taxonomy. And I've found through my research that current approaches tend to suffer from some shortcomings. First of all, many tools are only available via an online interface, or API. While this may be really convenient to use just for one time, it can actually be quite difficult to reproduce, because as a user, we don't have any control over the version of the database or the software, and that can change in the future. Secondly, there's a limited number of reference databases to choose from. So for a given project, we may not be able to implement the taxonomy of choice. And finally, most existing tools do not recognize the rules of taxonomic nomenclature. And for that reason, they may not be able to accurately match names, especially if that name matching is going to involve the taxonomic author. So I've tried to overcome some of these problems in my R package, taxastand. So features of taxastand include, first, it is run locally in R, so there's no need to call an online API. It allows usage of custom reference database, so that means it's highly flexible and can be tailored to a particular project. And when it does the name matching, it can do that using features like fuzzy matching, so that can account for slight variations in spelling, as well as matching that accounts for taxonomic rules. And I'll explain what I mean by that more in some later slides. And it's available from my GitHub account at joelnitta/taxastand. And here I'd like to give a shout out to Cam Webb, who wrote a program called Taxon Tools that is actually used by taxastand. And that's the part that handles the taxonomic rules. And if you want to find out more about Taxon Tools, you can check out his poster at this link here. So with that, I'd like to dive right into some example usage of taxastand. In order to use taxastand, of course, we have to install it, and it's currently only available on GitHub, so you can install that using the remotes or DevTools package. Also, since, like I mentioned, it uses Taxon Tools in the background, so you'll need to install Taxon Tools as well. Or alternatively, you could also use Docker, and Docker can run Taxon Tools for you. And I happen to find that Docker is much easier to use, so I would recommend that. Once you have it installed, we can start doing some name matching. So this is an example of name matching, and here we use the function tsMatchNames. It takes a query, is a character string, which here is the name Cryptonomys minutum. And then here our reference that we're matching it to includes two names, either Cryptonomys minutum or Hymenophyllum polyanthus. You'll notice that I've used the argument Docker equals true to tell it that we are using Docker instead of a local installation of Taxon Tools. This is what the output looks like. We again have the query, and we can see that it was matched to this reference name, Cryptonomys minutum. And the query and the reference actually differ a little bit in their spelling. And so this is a fuzzy match, which means that it's allowed to match within some threshold set by the user. So that was matching that happened to be a fuzzy matching. Now let's do this again and provide it with some taxonomic information. So this is the same function, tsMatchNames, but in this example, I've included the scientific author, and the input name includes the author K. Watts. And you'll notice that if we look at the reference, it's formatted a little bit differently. So we have this name here, Cryptonomys minutum, K. Watts, is the same name. The only difference being that it includes here the Bayesian name author. So that was Bloom, who named it originally in a different genus. Okay, and if we run tsMatchNames, we'll see that it was able to correctly match the input to this name that included that basioname author. And it did that now, accounting for the fact that this is the basionym. So you'll see that here in the match type. It's no longer fuzzy. It says it's auto basio minus, which means that the reference name included the basionym, but the query name didn't. So taxastand includes some, so this is what I meant by taxonomic rules. And so taxastand includes some other taxonomic rules that I don't have time to go into, but this is a really useful feature in which you need to do careful name matching based on the taxonomic author. Now, in most cases, we want to go a step further than that. We also want to map any synonyms to their accepted name. And in order to do that, we're going to need a reference database. Taxastand comes with a sample database of filmy-fern taxonomy, the family Hymenophyllaceae, happen to be some of my favorite ferns and my Zoom background. This is an example of what those data look like. And if you're familiar with the Darwin Core data format, you'll see that these taxonomic data are all in Darwin Core format. So this is an example of name resolution. Here we're giving the query Gornocormus minutum, and the reference taxonomy is that filmy-fern taxonomy. And if we look at the output, we'll see that the query was matched to a name Gornocormus minutus, which itself is a synonym and resolves to the accepted name Cryptonominus minutum. So here, I hope you can see how we can use taxastand to do custom name resolution of your input data. Now, of course, the key to doing that is having a well-maintained reference taxonomic database that includes both synonyms and accepted names. And that's where dwctaxon comes in. So the goal of dwctaxon is to enable simple error-free editing of taxonomic data in the Darwin Core format. And it's also available at my GitHub, joelnitta/dwctaxon. So we'll continue with our filmy ferns example. And here I've narrowed the example data set down even smaller to just 4 names for demonstration purposes. So that includes 2 accepted names, and they each have a single synonym. And this is what that looks like in text format instead of a data frame. So again, we have our 2 accepted names, each with a synonym. And let's say that we want to make an update to this taxonomic data. We want to make Cephalomines crasum a synonym of Cephalomines densinervium, right? So we have our new accepted species, and Cephalomines crasum is a synonym of that. But it actually has a few more synonyms, right? Because it had Cephalomines densinervium already had a synonym to begin with, Trichomonas, as well as this species already had a synonym. So when we make the change, we need to account for all of these different synonyms, right? And I hope this can, and this is just a very small toy example, but I hope you can see how if we had a much larger data set of hundreds of thousands of names, each with dozens of synonyms, that even just making one change like this can get quite complicated. And if you try to do that by hand, it's going to be very error prone. So the dwctaxon package provides a function dwctaxon that will do that for us automatically. So this is showing the same thing that I showed in text. Here I'm showing that in code using dwctaxon, and you'll see that the output is now a data frame where we have 3 synonyms that all map to this accepted name. Now, another really important function in dwctaxon is called dwctvalidate, and that's going to run checks on your data to make sure that your taxonomic data are all valid and good to use. So in this example, I tried to do a change where I update the taxonomy, but the new name itself was already a synonym. So I'm trying to make this name into a synonym of a name that's already a synonym. So that's not going to work. And if I feed that into dwctvalidate, it returns an error, and it tells me the name that's causing the problem. So this can be really useful for validating your data before you use it for name resolution. Furthermore, you may have noticed that these functions in dwctaxon all take as input a data frame and then return a data frame. So that means we can actually chain them together with what's called the pipe in R in order to apply a large set of changes to an overall taxonomic database. And this is just some example code to show how that works. And if you're interested, you can check out this repo here, fernphi/ToritoCat, where I did that to generate a taxonomic database of ferns. So in summary, taxastand and dwctaxon are a set of R packages that enable highly flexible and reliable taxonomic standardization. But I do want to end with a caveat that this level of customization might not be necessary for everybody. So maybe standard databases might work fine for your project. So I would say when it comes to doing taxonomic analyses, that you should choose the tool that will work best for you. And there's this really nice review paper in Methods in Ecology and Evolution this year that summarizes the available tools in R for doing that. So I'd recommend checking that out. And with that, I would like to thank everybody who made this research possible, as well as all of you for listening. Thank you very much.